Dzień dobry. Well, why everyone is laughing? Like usually when you say dzień dobry, people don't laugh. Yeah, dzień dobry. Mam na imię Nakul. I no zaczynamy. Kafka. Don't worry, this talk is not gonna be in Polish. I'm not gonna break your heart by my broken Polish. I didn't learn Polish. I just heard it so many times that I pick it up. So, all right, I hope you have a nice lunch. All of you have energy, which means you can focus on the session, not on sleeping, right? This talk is going to be about Kafka. So my name is Nakul. I work for a company called Confluent. We are the one who provide services around Kafka, around Apache Kafka. We also contribute back to the Kafka. And I work as a solution architect, which means I fly around and get to meet the people who are using Kafka out in the field and see what is good, what is bad, and what is ugly, right? All right, so let's get started. So how many of you like playing Lego? Whoa, that's like the hands goes up, right? So you are in the right room. I always loved to build Legos when I was a kid. Actually, I still love it. The idea of having the possibility to build beautiful structures, starting with a single piece, always amazed me, right? I always thought that the key to complexity is simplicity. One can build complex systems like this beehive, starting with a single and simple idea, right? Well, speaking about ideas, using traditional messaging system in a distributed world was not a very great idea. You see, spending time with Lego, I learned that every piece have its own purpose. And no matter how hard you try to squeeze it and fit in, it will simply not fit. Right? That's what I learned when I was building Legos. However, those things are not so apparent when it comes to software world. So I was working in a project where the team was trying really hard, spending a lot of time and energy and trying to fit traditional messaging system in a distributed world. And when you try to squeeze things, what happens? Well, in our case, it brought 3 challenges, right? And what are they? Scalability, throughput, and the last one, which you all love, right? Resiliency. So these are the 3 things which we face when we try to blend the traditional messaging system. So I started looking around, to find the piece that can fit in a picture. And then I stumbled upon this technology and this new open source project called Kafka. So it was the night time and I was like sitting in my home. And I come to know about Apache Kafka, and I was like, okay, this looks interesting. But you see, I don't buy a technology, right? I don't buy what a technology can do. But for me, why is very important, right? Why Kafka is different than other messaging system, right? Why it is better really promoted for distributed world, right? How it can solve my problem, right? So for me, why is very important. And that's what I started my journey in. And I found out that one of the things why Kafka was not just another messaging system was that it was something more than that. And what I mean is, for the starter, it supports both point-to-point and publish and subscribe. You see, in Kafka, each topic has its own journal, right? And this approach is completely different from, let's say, ActiveMQ, right? Where messages, all queues, are ended up in the same journal, right? And if we zoom in, a bit different in Kafka Journal, a Kafka Journal is nothing but bunch of log files, right? Like your log4j files, which keeps on rolling and appending and rolling and appending. And these log files contain some log entries. What a shock. Log files contain log entries, right? So that was making sense to me. And I started looking like, okay, the pointer doesn't work. So I started to look around what these files contain. So these files contain multiple log entries, and each log entry consists of two parts, which was a message length and message byte. And this name, which you see like 34 something.kafka, I was just curious as an engineer that what this name means. And it's turned out that it was based on the offset of the first message in a log file. So this is how Kafka looks like, right? That's how it supports point to point. And the next thing that blew me away was Kafka is always on system. It was designed to be always on. And hitting scalability wall is nearly impossible with Kafka. And it was not based on some paper out in the wild, but it was based on the data which I gather around and talking to some of my colleagues who works in these companies, right? And they, they tell the truth. They say, yes, we are doing it at a scale and without a pain, right? So that helps me a bit more, right? That it was designed as an always on system. On top of Kafka, it promotes the idea of pure data movement. Make data available again, right? We all works, in a team, and someone produce a data and some other team want to take a data, right? And then all sort of, crazy things starts to happen. If that data is not available, people start to get hacks and all those things. And the second thing which also disturbs is when you are introducing Kafka in an organization, you have your so-called beautiful money-making system, which is also called legacy systems, right? You can't throw them away. If you say we are going to throw them away, guess what? Your C-levels are not going to be very happy, right? And you will not have a Merry Christmas gift from them because that is the thing which is paying your bills, right? And Kafka Connect allow to pull the data from existing systems like Oracle databases or MySQL using Kafka Connect interface, right? And we will zoom in a bit during the end of the presentation what Kafka Connect is. So I understood that pulling and pushing data was doable in Kafka. When it comes to architectural design, it was inheriting more from the storage system like HBase, and that was something which I really spent my time digging around. Because traditional messaging system have a very different storage system comparing to Kafka, which was inheriting more from HBase, which means it was designed for retention, or at least it looks like it designed for retention when I was starting my journey with Kafka. And last but not the least, it was supporting even stronger ordering guarantees than a traditional messaging system, right? Yeah, you folks are right now thinking like stronger messaging guarantees than a traditional messaging system, right? And I can read your mind. So let me zoom in what I mean, right? How does it support? So let's say you have a server side and you have bunch of records coming in order on the server, right? So you have bunch of records which come in the correct order, right? And now you have bunch of consumers, right? Bunch of applications which want to consume from these topics. So far so good, but they want to do it in parallel, right? They want to do it in parallel. And what happens is that the server will hand out the records in the order. However, they will be delivered asynchronously, which means that record 1 can arrive to C2, then the record 0 can arrive, and then record 2 can arrive, right? So we send R0, R1, R2, but the order in which we get on this slide is R1, R0, R2, but it can be any different. Why? Because of asynchronous delivery. So how the traditional messaging system try to solve it? Well, they come up with a concept of exclusive consumers, right? We make such a situation when we add the word exclusive in front of consumer and solve that, right? It's trying to fix this problem, right? But with Kafka, we have strong ordering guarantees from the start and parallel consumption from the start. So till now, I was able to find that Kafka definitely excels at its messaging capability. However, what made me to invest more time with Kafka was simply because it's better than mom, right? And by mom, I didn't mean my mom, right? I mean Message-oriented middleware, right? So let's take a look what happens when you compare MOM versus Kafka, right? So in a message-oriented middleware, they take broker-centric approach, which means broker do a lot of hard work, like it will track the message, delete the message, and as they get consumed, right? It will know how to resend the message in case of failure, right? All this sounds a lot of work, right? And it's not trivial. There is a code written, right? There is no such thing like magic, right? There is a lot of code written to handle such things. And it gets trickier and trickier if you like add more and more things like tracking state per message, right? And Kafka say, well, you know, instead of broker-centric approach, rather than having a smart broker and dumb client, let's change the game. Have the dumb broker and the smart client, right? So it took client-centric approach. In Kafka, you will see broker is very dumb. You send the bytes, it writes the bytes, right? All the logic and magic, or let's say the smartness, is based on the clients, which means producers or consumers. Which means with great powers come great responsibility, right? So you should remember that. The second thing is that traditional messaging-oriented middleware, they were built on index structures like, right, hash table or B-tree, right? And the downside is that they must be kept in memory in order to get good performance, right? Well, Kafka use log structure. It use log-based stack. So there are no such restrictions out there. And what happens when you don't read message for a long time from ActiveMQ or from RabbitMQ? There is silence. Like, what shall I take? Silence as yes, no, or you don't know? Does anyone use here ActiveMQ, RabbitMQ? No. Like, he's like, no, don't look at me. I never used it. He's like, no, don't look at me. So what happens when you use traditional messaging system is things starts to pile up, right? And the more messages you have, you know, in your backlog, the slower the things starts to become, right? And which means retention impacts performance. The longer you want to retain something, the worse the performance get. With Kafka, since the design was inspired at a high level from traditional storage system like HBase, Cassandra, retention was a piece of cake, right? And finally, the outrage which happened in production, right? Production is better than Disneyland, and a lot of fun happened, and one of them is not so funny thing like outrages, right? And in case of outrage, we have a biggest blast circle, right, with traditional messaging system. And with Kafka, it won't cause infrastructure to slow down significantly, right? There are some parts where it can slow down, but not so significantly that your production almost comes to halt, right? So these were my findings, right? So Kafka made sense to me now. And I was more interested in how Kafka does what it does, right? And the answer is immutability, right? So if you take a look in Kafka, things are designed from the ground in an immutable fashion. Just imagine a world where immutability exists as a fundamental concept, right? Yeah, all of you are thinking like all my thread locks and all that stuff gone, right? It brings you a sense of enjoyment to think about immutability. And Kafka, a lot of its performance comes from immutability, right? So what Kafka did, it took simplicity and immutability and baked them together to what is called a log structure, right? Because at the end of the day, Kafka is nothing but a distributed tape, right? Which is built using log structure. And you can append on this tape. You can, so what I mean by append is, so if you are writing message A, then the message B will be written here, right? You can't go back and change the messages or change the order in which they were written. So it's only append only file. You always append, 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 right? And that was possible with log structure, right? I don't know if you have figured it out yet, right? But I'm originally from India, right? And as you know, in my culture, we believe in karma. So last time when I was in India, I went to a restaurant, right? And it was called Karma with my mom, right? This time I mean my real mom, not the message-oriented middleware, right? And you saw my mom in the picture, right? So we sat on a table, and you know, there was no menu there. So we are waiting. 10 minutes passed, and you know, I wanted to go because the owner of this restaurant happens to be my friend, and she invited me many times to her restaurant. But for some reason, I always will say, you know, my flight is early morning or my flight is late night, and I will not show up. So I went to her and I said, hey, 10 minutes passed, I didn't got any menu. What's going on? And she said, well, you are in Karma restaurant, and there is no such thing like menu. You get what you deserve. So I was like looking at her, and that's what summarized Kafka is, right? Hardware and log share the same relationship, right? Log structure is your good karma. Like, so this log structure is your good karma. And performance is what you deserve, right? So how Kafka get its performance, let's take a look. So we say Kafka is scalable, right? Why it is scalable? We are seeing, like, you know, Netflix recently announced they are doing 7 trillion messages, right, per day, right? There are companies out in the field whom I meet, they are doing petabyte of things, right, with Kafka. So how it is so scalable? Well, there is no such thing like magic. All the scalability is thanks to the log structure, how it is designed. So partitions can scale. And how partitions are built, you know, they are built on log structure. You can also read in parallel with consumption. So with Kafka. So what I mean, let's say you have a payment topic, right? So you have bunch of payments coming in the system, and you wrote some consumer, or shall I say, to be a trendy, a microservice, right? So you write your microservice, you call it some nice microservice, and you started, you know, reading bunch of payments and processing. And then you realize, well, this process is a bit slow, right? People are buying a lot more and more, right? Because it's Black Friday, right? And that's what people do on Black Friday. They log in and they just click buy everything blindly. So now the thing is, you need to scale your microservice, right? So what you do is you add another one of it, right? You add second one. And what happens is the load will get automatically distributed between them. Right? Under the hood, what happens actually is there is a repartition gets triggered, and there is a reassignment happens. So these two pieces of partitions get reassigned automatically to the consumers, right? And if you add more partitions, the same thing happen, right? It will automatically do it. Right? And what I mean this automatically, because we are all engineers and we don't like so much magic, right? So what happened under the hood is there is a topic there is a partition reassignment which gets called, and there are strategies which you can use. You know, so you can say, well, when the reassignment happen, I want first two partition to be assigned to this, next to be assigned like this. But she says, well, I want in a round robin fashion. So she can do that, right? So you can implement your own strategy to do that. And this comes out of the box, right? And Kafka has an impressive throughput, right? And it doesn't achieve this impressive throughput by importing messages in JVM heap and buffering them in user space, right? Because, you know, if we start to import things in JVM and buffer them to the user space, it means we will have penalty in the form of garbage collector, right? So how Kafka does it? Well, Kafka uses something called kernel level IO, right? And what it does is it directly copies from the disk buffer to a socket. So this is a kernel level instruction. It is also called zero copy, right? And Kafka utilizes it. Again, Kafka is standing on the shoulders of giant. And this is, my friends, this is the recipe how you can saturate your network. Because Kafka basically can pump through the messages as fast as your network interface allows. And there is no magic. It's only because of zero copy, right? You can do that. And that's also the reason when we deploy Kafka in production, the size of the JVM, the heap size and the configuration in itself is 6 gigabyte, 4 to 6 gigabyte, what we recommend. And rest of the memory or the RAM is used for caching, right? But Kafka itself doesn't need, because it never import those messages in user space, right? It just buffer them. I should not say the word never. It depends, I should say. It depends, because if you configure to not use zero copy, it will not use zero copy, right? So, if you are interested to read more about what I just said, how this kernel level IO work, you can go to this method transfer to. It's a, it's provided in Java API, and you can write your own zero copy things, right? Yeah, it's at the bottom. So I'm so sorry for that. So, all right, and now, when it comes to performance, there is one thing which we can't get enough, and that is cache. I mean cache, right? We can't get enough. Always when we want performance, we can say, well, add more cache. When we want to buy more things, we say, add more cache to my wallet, right? So cache is important, both in real life and in computer life, right? And in terms of Kafka, the thing which amazes me is it have basically piggy bank on operating system. It didn't invent its own caching strategy or something. So what I mean is Kafka rely on page cache, which is superior to maintain. And basically cache map is an in-memory cache, but supported by your operating system. So it doesn't design any caching or fancy things around it, which it have to maintain. And it means that if your service goes, offline on this machine and it comes back again, there is no need to, warm up your cache, because, well, the operating system was on. So the page cache is there, nice and warm and ready to be served. And that also helps when you go in production, because you have one less piece to care about. If you are building, real-world applications, there is something called exactly one processing, which you have to be aware about. What I mean is, let's say there is a Bob, or shall I say Jan, because we are in Poland. So there is Jan, who is, doing a bank transfer. He's sending money to Kasia, right? So he's sending 1 million zloty transfer to Kasia. And basically what exactly one's processing means is you want this action to happen once. Because if this happens twice, guess what? Kasia is happy and Jan is almost dead. Or he's speaking very beautiful Polish words, right? So in order to make Jan and Kasia both happy, we need to be sure that when he sends 1 million zlotys, it will end up here exactly 1 million, no more and no less. So that is what exactly once processing means. You want to process the message only once. But you will say, hold on for a minute, from where the hell all these duplicates coming up? Like why, the same message can be processed twice? Why? Yeah. And let me tell you why. So let's say you have a producer which is sending bunch of message to Kafka, right? And after sending the message, it is waiting for the acknowledgement, right? That, hey, I wrote the message. And at that time, let's say, some network glitch happened, and the message never reached to the producer. So what producer is going to assume? Producer will say, well, I didn't achieve any acknowledgement, so maybe the messages never reached there, right? And guess what? Producer will try again. So now you have duplicate messages, right? So this is one source. And we have a, idempotent producer which solves this problem, right? So we implemented idempotent producer pattern in Kafka to solve it. But then still there are places in which you can get duplicates, right? Let's say you are reading now from the tape, and again, remember, with great power come great responsibility, right? So it means the broker is very dumb and the clients are very smart, which means I get the messages, I process those messages, and the moment I process, I was gonna commit and I got java.lang.exception, right? Out of memory, error or something happened, right? And basically my application blew up. So I never committed my acknowledgement. Now what is gonna happen is, since it's 2019 and we like to automate everything, you have obviously automated that procedure, maybe using Kubernetes if you like your life or you hate your life, it depends, right? How do you see it? It depends, right? I'm a non-biased person, right? But let's say anyhow you have some automated mechanism which spin up this consumer, right? So now a new instance or the same process just get restarted and it started to read again the messages. Well, guess what? It goes to the broker and it says, okay, I want to read the message where I left the last time. And where it left? Well, it never committed back. So it will get from the beginning or from the specific part of the tape, the message. So that's how the duplicates comes in your life, right? That's how Jan becomes sad and Kasha becomes happy. So how do we solve these things, right? So we say, well, we created something called Kafka Transaction, right? And Kafka Transactions actually is not a new idea. It's based on a paper which was published back in the days by Shandy and Lamport, right? If you want, you can read more, and it uses markers-based transactions, right? And what it means is, for you, because you all code in Java, or how many of you code in Java? Wow. Yeah, that's why I assume in Poland people code in Java. I myself code in Java also. So, which means for you is they are non-JTA transactions, right? JTA transactions. So basically, if you are coming up with an idea, cooking something in your Friday, that, oh, let's create a prototype that I will write to a database and then write to Kafka and commit it in one transaction, then don't do it. Because it means you hate your life too much and you have nothing better to do. Because what will happen is, basing on the time, your prototype will work, right? If things stars align in the proper direction, it will work. But that just happens to be by chance. Because Kafka transactions are not XTA transactions. So you don't have a distributed transaction. So it can happen one transaction get committed and another not, right? So don't combine these two things in one, right? Don't go to Stack Overflow, copy and paste, right? I trust you folks for this. Don't do that, right? So what Kafka transactions are, so in a nutshell, let's say a producer wanna start a transaction. So we have something called transaction coordinator, which is, one of the broker have been assigned as a transaction coordinator, and we can have multiple of them to be highly available. And it say, hey, I wanna start a transaction. Transaction coordinator goes, it writes to a topic called transaction log. It's an internal Kafka topic which have some replication factor of 3 to be highly available. And it says, well, I am initializing the transaction with some transaction ID. And the producer called the method begin transaction. And it starts writing. It writes to one tape, to another tape, to third tape. It keep on writing and writing and writing. And at some point, it says, you know, I'm done. So when it says it's done, as you can see, the transaction coordinator is going to move the state to prepare. It's preparing a transaction to be committed. And what it means preparing it, it's basically making sure that the markers will be written in a proper order, right? So once the markers are written in a proper order, you see this C, the green ones, right? So these are the special messages which marks that a transaction is completed in a healthy way, right? However, I said that Kafka transactions are not XTA transactions, right? So what shook me for first time, maybe not so drastically as I'm saying it, right, is that in Kafka, when you are reading a message, and let's say I wrote this message, but I didn't committed this, right? Maybe a transaction timeout, right? Or when I wanted to commit network partition happen, or something happen, right? In production, all the time things happens. So don't ask me and look at me what happened, right? Something happens, because of which I couldn't commit. So what will happen in that case if someone is reading data from these consumers, or some consumers who are reading data from these partitions, they are going to see all those messages, which is also called like non-committed messages, because you never intended them to be seen, right? It's like exposing your dark secrets, right? And how do we solve that thing? So in Kafka, if you are using consumers, you have to make sure that you set the isolation level to read committed. And you will say, well, hold on, why I have to go and change this setting? Couldn't the Apache Kafka community figure out a better way to make the default, right? And the thing is backward compatibility, right? Like most of the things. So Kafka transactions were introduced after, you know, the initial consumer's design, right? So by default, we didn't have something like isolation level, and in order to be backward compatible, we set it as a default to read uncommitted, which means every old consumer can also read from the same topic or same partitions where Kafka transactions are implemented without changing anything in their source code, right? So that's the reason why they do it. Resiliency, right? So I mentioned the word resiliency. So from where the resiliency came? So in Kafka, the resiliency comes from replication. It have rock solid replication protocol. Even when you create a topic in Kafka, it's created as a replication factor 1. So it assumes everything is replicated, right? There are many other, you know, many things which can replicate. You know, you have various algorithms, ZAB and majority voting, majority vote based journal, etc. But Kafka have its own, you know, replication thing, and the inspiration comes from this paper, right? So if you are interested what it means, you know, you can read this paper. And what I mean that replication is rock solid, I mean it's supported at a protocol level. So imagine your traditional messaging system which were built, and then someone went and say, hey, I want to replicate something. And they say, all right, I can do that. I can add one more if and some more switch and some more else, and it's done, right? And as you all know, when we add more if, we have to add more else, right? But with Kafka, they thought about replication from the day one, right? So which means they took into design this concept of replication from the day one, from the fundamental unit, and that changes everything because they were able to bake it at a protocol level. And it relies on replication to avoid synchronous calls, right? What I mean by synchronous call, let's take a look. So let's say you are writing a file foo to disk. So you all code in Java and you are writing it, right? So when you write foo to disk, where is it? And I want you to speak this time. Please don't be so silent. Your silence is killing me. Tell me where the file is. So you write a file, foo to disk, where it is. On disk? On cache. Yes, it's written to buffer cache. And after buffer cache, where is it? Pardon? Yeah, so I'm very glad that you are participating. Yes, it moves to disk driver controller cache. Now where is the file foo? So someone say buffer cache. Yes, it is. You said like disk cache. And now where it will be? That's what your consciousness wants you to believe, right? But that's not where it is, right? So you are right, it is on disk, but there is disk caches. And guess what? These caches comes in two flavor, write through or write back. And finally, it's written to disk. Yeah, that's the reason why when you take your USB disk out, it complains it is not ejected properly, right? Now you can explain it to your mom. I mean, not message-oriented middleware. I mean your mom, right? So, as you can see, the universe is screaming to you that when you write something, it's not written to disk. Hence, you should not try to write directly to disk. So, Kafka don't write to disk, right? What I mean is, let's say I have a producer which is producing bunch of messages, right? And if I don't write to disk, right, if I write to the page cache, I can lose a machine and I lose the data, right? So how it able to prevent and write at the same time with a great speed? So it does it by replication. When I create one tape, let's say partition 0, it get replicated 3 times. I can control the replication factor, right? Then, as with all the replications, one of them will be leader, others will be follower, right? So let's say in this case, the leader is on the box A. So the producer talks to the leader. So producer started producing bunch of messages, and the other nodes, B and C, they started replicating, right? They start to replicate from it. So at this point, if you will look in your Kafka cluster, you will have something like this. You have a partition, which is P0, right, the name of the partition. The leader is the name of the box, A. And ISR is B and C. What this ISR means? It means in-sync replica. It means that if I lose this box, either this or this is fully capable to overtake because they have the same data. That's what ISR means. So let's say after some time, 10 minutes pass or X hours passed, and one of the boxes is slow to replicate. Maybe, the network link is running out of, capacity, or maybe, the box is doing too much other stuff. I don't know. But let's say one of them is replicating properly, another is not, or it's slow. In this case, Kafka is gonna remove that slow thing. So it's very aggressive to keep things in place, especially when it comes to ISR. So when the moment it notices that, hey, this box is slow, it will remove it from the list of ISR, which means this box is still alive, but if my box A goes down, well, guess what? C can't overtake because C don't have all the data, right? And that's what ISR is. And the same goes if you create another partitions, right? So if you create another partition, Kafka try to put the partitions on different boxes, right? And this time, as you can see, the leader is on broker 1, right? And why it does it? Because, you don't put all your eggs in one basket, right? That's the reason. So it don't put all the leaders in one broker, at least it try its best, thanks to rack awareness. Because if you will lose that broker, basically you are offline, right? For some time, right? Or depending, could be a long time. So that's why I distribute the partition. So again, in Kafka, a topic is nothing but bunch of partitions, bunch of files, and those files can be spread across various servers. And the same, if I create another partition, it will be assigned on broker 2, right? So as you can see that I'm not only resilience for a machine loss, but I'm also have evenly distributed my leaders, right, here. So that's what Kafka does by design. Okay, so how do I get streams of data into and out of Kafka? This is the question which, when I join Confluent, so before joining Confluent, I explore my journey. And then I join Confluent and people start asking me this question. And I'm like, okay, let's take a look what is in the box. So in order to get anything into Kafka or out to Kafka, you can write your own producers and consumers, right? However, that's maybe not the best approach. Why? Because I don't know about you, but I'm a very lazy person and I work super hard to be lazy, right? And that's what Kafka Connect API is. So Kafka Connect is a best effort both based by Confluent and community. So there are connectors which are created by Confluent only, which we sell, but there are also others which are created by open source community. But all those connectors allow you what? To take data. Let's say you have an Oracle database, right? And you want to import the data into Kafka. How are you going to do that? Well, you will say, I can write a producer. And I say, you hate your life. That's why you do it. If you like your life, you love your family and your kids, you go and use connector API. And why is that? Because there is too many details. There are too many moving parts, right? So when you start to import the data, you first of all need to find a way how to talk to our Oracle database, right? You need to have the scenarios in mind, what can go wrong, and many things can go wrong, right, when you are importing data. So first you need to know the specific technology, how you speak to that thing, right? So in Oracle they have Golden Gate. In what you call Postgres, they have Debezium, right? Debezium. So you need to first talk to them. Then you need to make sure that data is imported in the right way, right? So for example, we have a Hadoop connector where we make sure that when Jan sent a data or sent the transaction to Kasha, it will only be executed as a single message even if it is imported in Hadoop. And we do it by piggy banking on a trick, which is we give the file the name of the offset. And in Hadoop file system, you have the concept of unique file names, right? Which means that you should really should leverage this reusable piece of APIs for importing and exporting data, because you don't have to worry about all those corner cases, right? You just say, I want to import to Mongo and it import. I want to dump data into Kafka from Oracle or somewhere, it does it for you. And time is very important because you are sitting here listening me so peacefully. So how do we build a real-time applications, right, in Kafka and reflect it to our business need? We have Kafka Streams API, and these are the API which are built on top of Kafka, and they are basically, you can write standard Java applications. They are nothing fancy. And you don't need any separate processing cluster. So if you are doing Flink or other thing, you need a cluster to set it up. Here, you just need your Java code. You need to read the API, and boom, you can deploy it, just like a normal Java app, right? So you don't need any cluster. It's not required. It also supports exactly once processing. and it's fully integrated with Kafka security. So I see customers in the field where they really want to use such stuff, but they are also concerned about security, and we assure them that our Kafka, Apache Kafka Streams is also compatible with all the Kafka security standards. Finally, how do you do SQL with Kafka? Guess what? You just append the name K in front of SQL, and it becomes KSQL, and that's how you do SQL on Kafka. So KSQL is basically, if you don't want to write the Java code, you know, because you say, well, I am lazy person, and I even don't want to maintain a Java application because I have a very specific use case. You can use KSQL. KSQL is basically a wrapper on top of Kafka Streams. And KSQL queries, don't tell them to your DBA, because KSQL queries never terminate. You write a query and it's always on. Imagine, that's a nightmare for DBA in a traditional world. But that's what it is. So you write a query and it never terminates, because the events can come at any time. So that's what KSQL allow you. You can use any programming language. You can connect it via control center. You can you can write KSQL also in control center UI. You can deploy it in REST or headless mode, and so on and so forth. And the thing is, how do I maintain the data formats and ensure compatibility? Well, this is something which is really important, and I hope you can implement if you are thinking to do event-driven architecture with Kafka or without it. It doesn't matter. Still, think about how do you make your events in a proper schema, right? Because I have been working, or let's say in my past life I was working on one of the applications, right, where it became a jungle rule, right? They had the intention to publish events, and everyone was saying, okay, we publish events and everyone can listen to them, but then they wanted to evolve the events, and guess what? Whenever they changed something in events, the big data team became really, really angry. They were like, you are breaking our pipelines, right? So the changes were not communicated properly. And no one reads email, it's 2019, right? We just auto tag them to some label, right? So Schema Registry is basically your way to secure such a, or is your way to prevent such a use case, right? So what you have is, you have schema which is defined in Avro, and you can define there the rules, backward compatible, forward compatible. Basically, when you push the code, and you have a backward compatible, incompatible change, well, if you set up your CI/CD pipelines properly, you can detect it at that time. And even if you deploy it in production, the producer, like Kafka, will say, I can't accept it, because this schema is gonna blow up everything, right? So that's what the Schema Registry allows you. Some people like to say that Kafka is database inside out, which means if you have seen this presentation, you have seen that we talk about a commit log, and we have Kafka Streams API and KSQL to query the data. So Kafka can write the data in a very durable way, and you can also query it using Streams API and KSQL. And many people think, well, a traditional database is just a black box, so you have caching, you have query engine, commit log, indexes combined. But they like to see Kafka as a database inside out, which means you have moving parts which you can combine together and use it. It's another perspective, right? People use it, or they like to see it like that way, right? I thought this picture would be more prettier. So on the rendering. So if you are interested what Confluent platform is, right? So this is in a nutshell. A colleague of mine who works at Confluent, special thanks goes to him because he draw all this thing. It took him some time. But this summarize all the things, like how the Confluent platform is. if you have to explain it in your company, reuse this slide and be lazy, right? So takeaways are some things which you need to be aware is that Kafka again relies on the disk, right? So Kafka stands on the shoulder of giant, which means if your disk is not behaving properly, you will have some crazy issues. And one of them I saw was for a client who have a chatty neighbor deployed in cloud. And this chatty neighbor basically was sharing the same disk. So whenever he will chat a lot to the disk, the Kafka will not able to get access or will get slow access. And strange things starts to happen, right? So make sure if you are provisioning your Kafka, you give it a dedicated storage. Don't share the storage. Like sharing is caring, but sharing is also scaring, right? Don't share your storage, right? Share the code, not the storage. Also, it is possible that if you know, with great power come great responsibility. So you can really throttle your network with Kafka, and you can avoid it with quotas. If you add a new broker in production, guess what? Nothing happens by default. It will be standing doing nothing until unless a new partition is created or new topic is created, or you have to move existing topic. If you want to move the existing topic, we have a Confluent product. You can buy this or you can use by yourself. Go to the bin directory, run the script, take the JSON, execute on the box, right? But you have to do this because adding a new broker is not going to do anything by default, right? And if you are doing stateful processing, use compacted topic, and it will, because there is no sense of keeping all the history in place. So let's say if I ask you what is your bank balance right now, I'm interested how much money you get in your account, right? I'm interested in that state, not the history, until unless I'm Ujon Skarbove, which is interested in your history and even history of your friends, right? But I'm only interested how much money you got at this time, and this is your last state. So I can get it from the last message, and that's what happens. If you need to maintain the states, you are interested always, or in most of the cases, in the last message of the state. And there was a problem back in the days that Apache Kafka, someone shut down on the production like this with a kill command, and it create havoc in the production, right? The problem is solved right now. We make a fix in Kafka, which means you should upgrade your Kafka, right? Automate everything, upgrade Kafka, be trendy people, right? So how Kafka helped to solve our problem? Well, Kafka is always on system. It's very hard to keep it off, or hard to turn it off. It's designed from ground up for distributed world. You can use or maybe look at it as a database inside out, and it's fun to play Lego, right? So thank you, and if you have any questions, I will be around to answer.
Nakul, Mishra.